the equations, you're going to solve for what variable. So like I said, I always look for the simplest equation and the simplest variable to solve for. So if you're looking at that first system right here, that 4x plus y equals 3, which variable in what equation is the easiest one to solve for? Yeah, the 4x plus y equals 3 is the easiest equation, and solving for y is the easiest variable. Because it involves one thing, move the 4x. So that's the easiest. Whereas, if I picked the other equation, 7x plus 2y equals 4, I would have to move, let's say I was going to solve it for y. I'd have to move the 7x and then divide by 2. So that's a two-step process, whereas the other one's just a one-step. So trying to choose the easiest. So looking at the second set that they have right here, what variable, which equation and what variable? The bottom equation and what variable? The x. Because you can just move that 20 and you're good. So in the third set, what equation, what variable? Top. The y. Now the last set, it's pretty much a toss-up. Because all of them is going to take 2 steps to do. However, the top equation has bigger numbers. So I'd probably choose the bottom equation. And if I'm doing the bottom equation, I would solve it for x. Because both of the other numbers, 4 and 18, are divisible by 2. So I wouldn't have any fractions. Whereas if I tried to solve the bottom equation for y, I was trying to get y by itself, I'd end up dividing these, and 18 isn't evenly divisible by 4. There's 2. That end up in a fraction. So just to avoid fractions, I'm going to solve the bottom one for x. That doesn't mean that that's the best way, nor does it mean that it's the only way. You can do it the other ways. They'll work with fractions. It's just a little harder. Okay, so now we're actually going to do it. So this first, number 1, is this first system. So we said we're going to solve the first equation for y. So here it is. They've split them up, put them next to each other. Because that's how you do it. It makes it easier. I'm going to take this first equation and solve it for y. So I'm just going to move the 4x to the other side, and I get y equals 3 minus 4x. Okay, so that's your first step. Now, the next thing we do is substitute it. That's why this is called substitution. I'm going to take all of this, and since y equals all of that, I can plug it into the other equation where y is. So I'm going to have 7x plus 2, and now instead of y, I'm plugging in that information, 3 minus 4x equals 4. Now you should have an equation with one variable. If you get to this point and you have an equation with more than one variable, then you've made a mistake and you've plugged in the wrong place. So when you get to this point, you should just have one letter, and I do. I have x's only. So now I'm just solving for x. So I'm going to distribute this 2. So I have 7x plus 6 minus 8x. At this point, you are just solving equations, which we've already learned how to do, and we've practiced quite a bit. So I'm combining like terms. 7x minus 8x is negative x. Just continuing to solve. After all my solving, I get x equals 2. Now that's only part of your answer, because remember the answer is an ordered pair, so you need both x and y. So you take this x, plug it back in right here. So now I have y equals 3 minus 4 times 2. So So now I got y equals -5. So now I'm going to make my ordered pair, because your final answer is an ordered pair. Please check them and make sure you put them in the right order. X comes before y. So my ordered pair is the ordered pair 2, -5. Alright, number 2, we said that this second equation, we were going to solve it for x. So they've split my two equations up, and I'm going to solve this one for x, get x by itself. Easy enough. You're just going to take this -20 and move it to the other side. Once you have one variable by itself, now the substituting begins. So I take all of this, plug it right here where x is. Check once you get to this point, make sure you have all the same letter. And I do have all y's.
Is your like
Now I'm just solving for y, so now it's just an equation.
because you had 9x, does it kind of like cancel when you multiply it by the whole equation right there?
I've distributed it.
Oh, okay. I see what you're
So
saying.
9 times 7 and then 9 times 20. Once you've distributed, and I just put some negative. Now you just combine like terms and solve for y. Okay, so I got down to here, I divided by 74, and I got y equals -2. Now that's just half the answer, because you need an ordered pair. You need x and y. So now I have to take that -2 and plug it back in over here. So 7 times -2 to figure out what my x value is. So I get x equals 6. So again, always check and make sure that when you write your ordered pair, you put them in the correct order. X comes first. So my ordered pair is the ordered pair 6, -2. So far, so good? It seems like a lot, like a really long process. This is not my favorite method, because I think the other method is not quite as long of a process. However, sometimes this is the only method that will work. And then sometimes it's the most practical method, because sometimes they've already solved something for one variable. Like, for example, this problem that we did with the graphing, number 14. If you look at these two equations, if I did not have my calculator, this top equation's already solved for y. So it'd probably be easier to just go ahead and plug it in than to try to do any other method. So sometimes it's the best method, even though it's kind of long. Not my favorite, but sometimes it's the best. Okay, so for number 3, we said first equation, solve for y. So we're going to get y by itself. This is actually a two-step process, but it's still the easiest one to do. I'm going to move the 8x over. That leaves me -y equals 90 minus 8x. But I need just y. So you do have to fix that, to change all the signs. So y equals negative 90 plus 8x. Now that's what y equals, so I'm going to take all of this and plug it right here. Now the numbers are pretty big, but it's still the exact same process. When you get to this step, make sure you check to see that you have just one variable. And I do, I have just x's. Now 14 and 22. Alright, so number 4 is just slightly different because it's not quite as straightforward, which thing we're going to solve for. Like I said a minute ago, I want to try to avoid fractions. So I would either solve the first one for x, because 9 and 51 are both divisible by 3. Or I would solve the second one for x, because 4 and 18 are both divisible by 2. If you solve either one of them for y, you're going to end up with fractions. It'll work, but it's more trouble. So I'm going to solve the second equation just because they're smaller numbers. That's my primary reason. I'm going to solve this for x. So I'm going to move the 4y over. And then divide everything by 2. Once I have a letter equal something, then the substituting starts. So I'm going to take this, substitute it right there. We got y equals 8. Take that. That's only half the answer. So I get the order pair negative 17. Everybody okay? Alright. Says sometimes solving systems with substitution can yield strange So let's try these. Which equation, what variable? First one for y. Okay, so I've distributed my 2. So I now have 10x plus 4 minus 10x equals 9. So I'm going to combine like terms. So I have 10x minus 10x. Well, that cancels. 10x minus 10x is now nothing. So I'm left with 4 equals 9. No more x's. Does 4 equal 9?
No solution.
This one's no solution. Which equation, what variable?
The second one for
X. You can do the second one for X, or you can do the first one for X. Probably about the same, but I'd choose the second one also because the small numbers are smaller. I solve for X and I get 8 plus 3y. So I'm going to plug that back into my other equation where X is. So I have negative 24 minus 9y plus 9y equals negative 24. My minus 9y's, one's minus, one's plus, that cancels out. And I'm left with negative 24 equals negative 24. Well, negative 24 does equal negative 24. But I don't have any y's anymore. My variable completely canceled out. If your variables completely cancel and what you have equals itself, this one is all real numbers. Okay, so if you end up with an equation that is not true, like we ended up here with 4, that symbol means doesn't equal. When we did it, we had 4 equals 9, but 4 doesn't equal 9. So 4 does not equal 9. That means this is not a true statement. This system has no solution, or it is inconsistent. Graphically, what would be true if we put this in the calculator? If it has no solution, what's true about them graphically? They're parallel. If you end up with an equation that is, in this case, it's always true, no matter what we plug in. The system has infinite solutions, or it is consistent, independent. Graphically, the lines are coinciding. Okay, so they gave you 4 more problems for you to work on solving by substitution.